Welcome and hello. This is a video exercise in HEC HMS. And for this exercise, we are going to be modeling a storm event at Redwood Creek in April 2018. All right, in this exercise, we will build an HMS model from scratch and model a storm event that occurred in early 2018 in Northern California. Also, in this video, I've left a few links in the description. The first link is this page here that you're seeing on the screen. This exercise is loosely based on the information from this tutorial, but not entirely for a number of reasons. But what I want to do first is to scroll all the way down to the bottom of this page and then scroll up a little bit. Just above the references, there's this redwoodcreek.zip file. I'm going to go ahead and download that and then just store it in with my project files. That way I can use it as a reference. I'm going to refer to this Redwood Creek files as the reference project. Okay, so that's downloaded. Let me go ahead and see what's inside here, Redwood Creek. And now here are the typical files and folders I would expect to see inside of an HMS project. So I'm going to go ahead and go up one level and then find a place on my computer I want to keep that. And then I'll drag it over and then let that copy and unzip. And now I can delete the original zip file. All right, so I'm going to actually create my own new HMS project in this same directory. That'll be what I'll call my project, and this Redwood Creek project will be called the source project or reference project. So let's go ahead and do that. I'm going to bring up a new version of HMS. Here we go. Click New. I'll give the project a name, and then click the folder icon to navigate to where you want to store this project. Okay. US customary for units and create. All right, let's go ahead and create a basin model and then click on basin 1 or whatever you named it to bring that map up onto the screen. What I want to do first is bring in the terrain data so we can create our watershed. So let's go ahead and find this Redwood Creek. Here in Google Earth, I've got a map up. This is San Francisco Bay Area in Western United States, specifically the state of California, Northern California. And what I'm looking for is Redwood Creek. Okay, I think it's right here. There should be some labels that pop up. If I go back to the instructions, I do see the watershed right here. It's looks a few miles north of the peninsula. Yeah, so there's a scale, so maybe 4 miles up. Grab the measuring tool here. Okay, I have to zoom out a little bit more, I guess. Okay. Oh, Muir Beach. Okay, yeah. So it's right at that Muir Beach location. All right, so this is the area right here. This is the watershed. I'm going to go to the USGS website to download these files. This is the downloader page. One of the other links in the description will take you to this page as well. So let's go ahead and zoom in. I'm just going to look for Muir Beach. Here's that Redwood Creek right here. So we're in the area. I'm going to zoom out a little bit more. So this should be plenty of area. I'm going to click on the elevation products. And then for this project, I'm going to use 1/3 arc second DEMs, which is about 10 meters, I believe. Well, let's see if that's available. So I'll click the search products button. Okay, I'm going to download this first file right here. And it's downloading. It's about 212 megabytes, so it's pretty good size. Okay, that's downloaded. Let's go ahead and, okay, so it's a single TIFF file. I'm going to navigate to my project directory, terrain, and just move it into the terrain directory there. Okay, next thing I want to do is crop out just the area of this terrain data before bringing it into HMS. That way, the processing tools built into HMS won't be overloaded or take forever. So to do that, I'm going to open up QGIS. All right, QGIS is open. I'm going to create a new project and just go ahead and save it. All right, here is my project directory. I'm going to put this in GIS and I'll just call it project. First thing I want to do is set the coordinate system. So I'll go up to project, properties, coordinate reference system. I'll use NAD83 and then apply and OK. All right, now let me bring that TIFF file in. So that'll be in layers, add layer, raster. And then I'm going to navigate to that terrain directory right here. Okay, here's my TIFF. Add, close. Perfect. So the area I need is just right up here. For instance, I want to say it's this creek right here. Let me grab the measure tool. It was about 4 miles north of this point. Okay, that's in meters, miles. Yeah, so it's this right here. Now that I know the general area of my watershed, what I'm going to do is create a polygon shapefile and to use as a mask, and then only clip out the elevation data from this map to use in HMS. Therefore, I will be minimizing the processing time upon HMS GIS tools. All right, so to do that, I'm going to go up to Layer, Create Layer, New Shapefile. Then I'm going to go Polygon. For the file name, I will put it in my GIS directory right here. Perfect. I'll call it watershed and then buffer.shp. So it'll be the watershed itself plus an extra buffer range or halo around that watershed. All right, and then I also want to change the coordinate system to be consistent with the TIFF file. That's this one here. And okay, great. So that is now in my layers panel. I'm going to go ahead and click edit, add a polygon, and then start single left clicking around the area that will be my watershed plus buffer. Okay, right click to finish. I'll just add an ID, 1, and there we go. Save. And actually I need to save here, stop editing, and I think I'm good. I'm ready to now use the raster extraction tool and then clip raster by mask layer. Here I'm going to select my TIFF file, the USGS file, and then here's the buffer. I think everything else should work. I shouldn't have to set the coordinate reference system because those two layers are already using the same coordinate reference system. All right, so that looks good. Let me turn off the original elevation layer, and now you can see this is the file that I want. I'm going to save this TIFF file in the terrain directory of my HMS project and then be able to import it nice and easy. Right click, export, save as, GeoTIFF, that's correct. And then this is the correct coordinate system. Just need to keep checking that. And then for a file name, I'll just call this USGS cropped. All right, and okay. All right, I think we're done with what we need to do here in QGIS. I'll save the project, and then I can minimize QGIS. We're back in HMS, so I'm going to go Components, Terrain Data Manager, New. I'll just call this Watershed Buffer, and next. Okay, let's navigate to that USGS cropped.tiff. Maybe that's what I should have called it. Vertical units is in meters, and looks like we're good there. All right, so there's that. Good. And then basin 1, I'll select watershed buffer and then save. And looks good. I can skip that step. I'm going to double check my coordinate system. Okay, I think that's right. If I have any problems, I can just load in the projection file. And I do have a breakpoint here because I was messing around with this exercise earlier, but I'll redo this step, so don't be confused by that. Let's go ahead and use the GIS tools now, starting with pre-processing sinks. All right, that looks good. And then the next is the pre-processed drainage. That should be pretty quick. Everything should be pretty quick since we have a small terrain, even though it's 1/3 arc second. And then after that, we'll identify streams. I'm going to say 3 square miles. Let's go ahead and see if that works. And then, all right, cool. So we have our layers. Let me toggle off some of these layers here. So all we have here is the identified streams layer. Okay. Let me go ahead and draw properties and just modify the property so I can see it a little bit easier. I'm going to go manual and then say there's 2 classes. So we'll go with a white color if it's not water or under a threshold of, we'll say 10. And then if it's under, say, 10,000, that'll be blue. Okay. Apply. Okay. All right. Perfect. So this is our identified streams layer. I'm going to zoom in here on the outlet, go GIS, breakpoint manager. So I'm going to remove that other breakpoint, delete. Okay. Now let's go ahead and place a breakpoint where we want it, right at the very end of the identified streams layer, and click create. All right. So let's save that. Next, we're ready to run the main delineation tool. That's right here. We'll call it subbasin, reach, yes, junction, underscore, and then click delineate. All right, so that's working. All right, great. Looks like we got one subbasin. So the 3 square mile setting was good. This is a very small watershed compared to some of the others we've seen in other exercises. I'm going to turn off some of these layers. We don't need identified streams. Next, what I want to do is download the discharge data, which was the observed stream flow at this discharge location at the sink event, which is the base of the watershed. Here in the instructions near the very top, we have this example watershed heading. And then just below that, we have this link right here that takes us to the location where we can get the historical stream flow data for that 5 days in April 2018. So if I click on this link right here, it opens up a new tab. And I have the option to, oh, okay, it's still loading here. I'm going to click on this link for legacy real-time page. And then I believe I should be able to put the dates in. All right, here we go. I have a begin date and end date right here. So I'm going to put in, this is going to be from April 5th, 2018 until 2018, April. And then it says the 9th of noon, but noon, I'm going to say just the 10th right there. All right. And then the data I want exported, I want it to be either a table or tab separated. I don't want a graph per se because I want to be able to put this into a time series data set in DSS view. Discharge, this code 60 is the only one I really want. I'm not interested in the gauge height. All right, let's go ahead and click go and see what happens. Okay, so it's just giving me text onto an HTML page. That's not exactly what I wanted, but I can deal with it. Let's see. It looks like it's a 15-minute time step, which is more detailed than I'm used to, so that's cool. And then let's just copy all that data, I guess. Right now, I'm just going to put it into a text file. All right, so what I'm going to do is just open up a text file, paste it in, and then let me go ahead and save that to my project's data directory. Here's the project data, and then I'll just call this streamflow raw.txt. All right, so what I want to do here is go to the very top. I want to remove this first line of information because it's just agency ID, the site number, and then this value right here, this 4.06, this is the actual value that I want. So that should increase after the storm comes in to much larger numbers. Here it is. Okay, so gets up to almost 1,000 here. I think it does. Yeah, further on, it does go above 1,000. Anyway, back to my point. Let's delete this first record here. I'm going to save this file, and then I'm going to open up an Excel file. Before anything happens, I'm just going to save this Excel file. I'm just going to put it on my desktop for now. Stream flow formatted, and then save. Okay, I'll click on the data tab up here, get data from a file. It'll be from a text file. Right here is the project, here is the data directory, and then here is the text file. So let's give it a moment while it's trying to parse out that data. All right, very cool. So column 6 is the flow. I don't care about the other columns because I already know that data. Here is the data I want. That's cool. Let's go over to DSS view now and then create a time series data set for that observed discharge data. Let's start with creating a DSS file. Here's the project right here, exercise 58. And then I'm going to put this in data. And let's see, I'll call this stream flow observed and create. Okay, thank you. And then let's go ahead and create a manual time series now. So data entry, manual time series. For part B, I'm going to call this Redwood Creek. That'll be flow. The part E is the time interval, and that's going to be 15 minutes. So let's change that to the 15 minutes. Okay, I think I could call this observed OBS or just write it out. The start time is going to be whatever the first record is in our Excel file. So that was April 5th at midnight. So let's go back to DSS view. It's going to be APR. And then the start time will be 0 to 100 hours. The units is in CFS. And then for flow right, this is going to be period average. All right, let's go grab that data here from column 6. I'm just going to highlight it all, Control C, then go back to here, Control V to paste. I think that pasted in. Okay, we'll go ahead and check it out in just a moment. All right, so it's saved, and let's look at that streamflow data. Okay, I made a copy of it, so it now seems to work. So if I click on the plot, we see the hydrograph. This is the observed discharge flow. I just observed and observed one. I had to create some unique name to it. Not quite sure why it wasn't working the first time though. Now what we need to do is go back to HMS, create a time series data set for discharge gauge, and then assign that to the sink or the subbasin, both really. So HMS, we're going to go to Components, Time Series Data Manager, Discharge Gauges, We'll call it gauge 1, sure. And then go ahead and define that by clicking on the gauge 1. This is going to be a DSS record. And then I'll click on the file folder, navigate to that data directory. Here it is. And it should be the one and only path in there, or well, I guess this one right here with a suitable range. And then there we go. All right, save. So now I'm going to click on the sub-basin, go to the Options tab, and then for Observe Flow, select Gauge 1. And then I'm going to do the same thing for the sink. Click on the sink, Options tab, Observe Flow, Gauge 1, and save. All right, next we need to do a few more things before we can run our simulation. That includes creating a controlled specification. So I'll just create one here. We'll call it Control 1. And then for the data itself, I will go ahead and type in the start, which will be April 5th, 2018, and it'll go until noon of April 2018 as well. Okay, and then 15-minute time interval, that's correct, and then click Save. We also need to create a meteorologic model, so I'll go up to Components, Meteorologic Model Manager, New. I'll call it MET1. So let's click on MET1. And what we're going to do here for precipitation is the gridded precipitation. And then for replace missing, I'll change that to set to default. For gridded precipitation here, I'm going to select my grid. Now I don't have a grid yet. And this is a pretty involved process of getting the MRMS data and the PRISM data and then normalizing it together and bringing in as a grid. So if you're interested in that step, the previous exercise, exercise 57, titled Importer and Normalizer Tools, I go through this exact same process using this exact same watershed. So if you wanted to do that using this watershed, I invite you to do that. But you also have to export this watershed as your shapefile or your basin boundary. So you go up to GIS, export layers, subbasin, click next. I'll just go ahead and do that step with you to get started if you're interested. You can just call it subbasin, and then we'll put that in the GIS directory. Okay, so we have watershed buffer. We could actually just call it watershed. There's only one subbasin in the watershed, so either way is fine. Okay, and then finish. So that's saved. You're ready to continue on with exercise 57 if you want to generate the precipitation grid that we'd be using in this model. But for me in this exercise, I'm just going to go to that source directory, which was this project here, Redwood Creek, data, and then mrms adjusted.dss. So I'm going to go ahead and copy that and then go back up to my project, data, right click, paste it in. Let's go ahead and check out what that data looks like. So I'm going to open up that DSS file. It's in data and then mrms adjusted. Here is our precipitation. So I'll select all the records. First, I want to just peek at the gridded data. It's only a 3x5 grid cell, so it's very small. And then it's using this 2000 meter cell size. So, oops, let me go ahead and look at some cells now. Okay, I had to toggle in a day and a half, and finally I'm getting some precipitation values here. Okay, it looks good. I'm back in HMS now, and I want to create a gridded data set. So let's go with precipitation grid sets, new. And then, yeah, we can just call it grid 1. The tutorial tells us to name these grids certain things, but we're only going to have one precipitation grid. So I'm going to click on that precipitation grid, change the source to DSS, and then navigate to that data directory, mrms adjusted, and then click on this button, click the first precipitation grid set path name, and then save. Back in the meteorologic model, I'll click gridded precipitation, and now I can select grid 1. There's a few more subbasin parameters that I need to set, and then we'll be ready to create a simulation and run it. In the instructions, if you scroll down further, there's a few tables of that data. So for instance, we have the deficit and constant loss data, as well as the transform data and the base flow data. I'm not going to be using this transform method for a few reasons. First of all, this tutorial requires usage and knowledge of HEC RAS, some of which goes beyond my current understanding, although it is motivation for me to learn HEC RAS and make some HEC RAS videos. But let's go ahead and start with deficit and constant as the loss method. I'm going to pull this over to the side so I can read it at the same time. Select the subbasin, and then what we're going to do here for loss method is select deficit and constant. I need to go back actually and also say that the discretization method is going to be structured. For the transform method, we're going to be using mod Clark and then a linear reservoir for the base flow. All right, let's go through these tabs real quick. Discretization, I'm going to be using SHG and 2000. So I'll click Save. And then while I'm here, I'm going to go up to GIS, compute grid cells. All right, and then I'm also going to compute the grid cell file, SHG 2000, next, and then finish. It'll just save in the default project directory as the .basin file. Let's just confirm that we have a 3x5 grid across our watershed. So I'll go up to View, Map Layers, then Discretization Layer. Okay, there we go. So 1, 2, 3, 4 by 3. Maybe there's a fifth one right down here. Okay, I'm going to click on the subbasin again and then click on the Loss tab. Here in the Components Editor, I'll use an initial deficit of 0.5, maximum deficit of 8 inches, and then the constant saturated hydraulic conductivity of 0.3. All right, leaving the percent impervious to 0%. And then the next tab over is Transform. This is for Mod Clark. I'm going to use 3 hours and 4 hours. That's probably too long, but let's see what happens. And then for the base flow, this is the linear reservoir parameters. I'm going to select 2 layers. And then discharge will be discharge per area. And then that will be 0 for layer 1 and 1 for layer 2. The groundwater fraction is going to be 0.5 and 0.5, so an equal split between layers. And then the coefficient for layer 1 is going to be 5 hours, and for layer 2, it's going to be 30 hours. Okay, so the number of reservoirs will be 1 for both layers, and I'll click Save. All right, we're ready to run the simulation and see what happens. So let's go up to Compute, Simulation Run Manager, New. We'll call it Run 1, use the one and only basin, Met Model, and Control Specification. All right, let's go ahead and also select that simulation and then run it. All right, it ran. So let's see what the results look like. I'm going to right click on the subbasin, view results, graph, and this is interesting. So we have a hyetograph on the top. This is our typical subbasin plot, right? Hyetograph on top, hydrograph on the bottom. It looks like our peak discharge is similar. However, it's delayed too much. Remember I mentioned that those Mod Clark parameters of 3 and 4 hours may be too much. That's probably what's causing this. Also, there's a distinct double peak in the observed flow, which is this black line, and then the computed outflow doesn't really have a first peak, just a second peak. So there's obviously some calibration that can be done. Let's go ahead and just change those Mod Clark time values real quick, and then run the simulation one more time, and then call it good. This exercise is not focused on calibration. It's more focused on setting up the model itself. 0, let's go 2 and 2 for those 2 parameters, and then run it one more time. Okay. And then right click, view results, view the graph. Okay, so not quite. I mean, it looks like we have 2 distinct. Let me actually look at the sync element here instead. So this is zooming in on just what I'm looking for, just the discharge from that subbasin, from the whole watershed, really. As we can see, our observed flow is in black. That's the stream flow data we download from USGS. And then in blue, we have the computed results. Again, there's too many variables for me to get into on calibration. That's not the focus of this exercise. But we are done here. We've done a number of things by setting up this hydrologic model for Redwood Creek in HEC HMS.